Okay, so for 9.2, we're going to introduce or maybe refresh on some trigonomic functions. So the 6 trigonomic functions are sine, cosine, tangent, cosecant, secant, and cotangent. So these 3 are the standard functions, and these 3 are inverses. So each makes a pair, and each pair has one co in it. So you have sine and cosecant, then you have cosine and secant, then you have tan and cotangent. So there's always one pair. If you plot a point, its coordinates are x comma y. So if you drop a line and make a right triangle, this length would be y, this length would be x, and then this is the radius of the circle that our angle would make if it moved around. So to get sine, you do y over r, and since cosecant's the reverse, it's r over y. Cosine is x over r, secant's the reverse, so it's r over x. Tangent is y over x, and then cotangent would be the reverse, x over y. So these are things you want to remember. You need to know the 6 functions, because a lot of times you're going to be asked to name the 6 functions, or depending on what you're using for technology, you might need to remember which ones are the reverse in order to get your actual answer. When you have a right triangle here, x and y you're going to know because you have that point. So it's going to tell you x and y. To get r, we're going to use the Pythagorean theorem. X squared plus y squared equals r squared. So to get r, you'd take the square root of both sides. So you can always find r once you have those points. Then you can find any of the 6 functions. Now on a graph, we have 4 quadrants. Quadrant 1, quadrant 2, quadrant 3, and quadrant 4. Here, x and y are both positive. Here, x is negative, y is positive. Here, they're both negative. Here, x is positive, y is negative. So in finding those, when you plug them in for your x and y's, you're going to always have certain signs for each thing. So in quadrant 1, everything's positive because all the x's and y's are positive. So whether you have x over r or y over r, they're all going to be positive. In quadrant 2, where the y is positive, your sine and cosecant will be positive. Everything else will end up negative because of that negative x value. Quadrant 3, tan and cotan are going to be positive because you have x and y, so the negatives are going to cancel each other out. Everything else will be negative. And then in quadrant 4, your cosine and secant will be positive, and everything else will be negative. So by memorizing this, or at least being somewhat familiar with it, it can make your life a little bit easier. Calculators and will give you the right value anyway, but it's just good to know, based on that point, what you should expect for a positive or a negative answer. Sine and cosine are always less than 1. You could get a positive, you could get a negative. So if you take your absolute value, they're less than 1. So if we look at this one, the square root of 3 is greater than 1. So this is not possible. If we look at our cosine, 0.5 is less than 1. So it is possible to get a cosine value of 0.5. Secant and cosecant, and I wrote those completely backwards. Since they're the inverse of sine and cosine, they're going to be flipped, so they would always be greater than 1. So if we look at secant of 0.6, well, 0.6 is less than 1, so that's not possible. Cosecant, 2.9, that is greater than 1, so this is possible. And then tangent and cotangent are fractions of the sines and cosines. So those can be any real number, positive or negative, decimal or greater than 1. It doesn't matter because it all depends on what you get. So any value is possible for tangent and cotangent. So if you're asked, is it possible, you're basing that decision on whether they should be greater than 1, less than 1, or any real number. The grade is the slope of a hill. So if you have a hill with a truck on it, me and my wonderful artistic skills, the steepness of that hill is the grade. And it's written in a percent. So if you've ever heard like that road is 7% grade, that means it's 7% steepness. To find the grade resistance or the gravitational force, so gravity versus the weight, you're going to use this equation. So the angle would be the angle the ground and the hill make. W is going to be the weight of the vehicle on the hill, and then R is your resistance. So let's try a problem. A downhill grade is modeled by the line y equals negative 0.06x. So you know you've got a down line with a slope of negative 0.06. So if they ask you what is the grade, we have to turn negative 0.06 into a percent. Move the decimal point twice, you get negative 6%. The negative tells you it's downhill. If it was positive, it'd be uphill. Now, what is the approximate grade resistance for a 3,000-pound car? So if we go back to our initial equation here, I think it was sine. Yep. We just said the angle is 6%. So if we wrote that as a point, it would be negative 6 over 100. So if we did a point up here, right, because we'd want to be able to make our standard position angle, this would be negative 6 over 100. That's how we get negative 0.6%. So we turned our percent and our decimal into a fraction. Now we have to find R. So R is the length of this line in order to figure out our angle or to our sine information. We don't need to know the angle because we know that sine equals y over r. So we just have to find r. So r is x squared plus y squared. So if we add those together, we get 10,036. And sine is y over r. So for this equation, our weight is 3,000. And sine of theta is y, which was 100, over... Nope, I did that wrong. I have the x and y backwards because, let me get a different color here. It's a downhill, so we're doing this. So this should be 100 and negative 6. I wasn't paying attention to the line I drew. So this should be negative 6 over the square root of 10,036. If you plug that in a calculator, you get negative 179.7 pounds. So the gravitational force or the resistance for a 3,000-pound car on this road would be negative 179.7 pounds. There you go for 9.2.